This is the March 2013 calculator paper, and again this is a series of videos which are designed at showing you how to get up to a grade C, maybe even a grade B, but not going through the whole paper. So for this paper, 32 marks was enough for a C and 51 marks was enough for a B. Now from the materials that we've covered with my class this year, that's mostly the top 40 materials, there's 50 marks that we can get, and maybe there's another 16 as well. So plenty for a C and maybe even enough for a B. So let's have a look at the questions. So this first one is asking you to draw this information in a stem and leaf diagram. Now there's a nice big gap, and then there's a stem and leaf diagram table for you at the bottom of the page. The idea there is to make sure, as with most stem and leaf diagrams, draw it out twice. And what I mean by that is like this. We'll look at the numbers here. We've got a 19, we've got some numbers in the 20s, we've got some numbers in the 30s, we've got some numbers in the 40s. So our stems are going to be 1, 2, 3 and 4. And then let's go through. Well, 19, so I'll put a 9 there. 18, so I'll put an 8 down. 20, so I'll put the 0. 25, 37, and I'll put all these numbers down, and you'll notice that what I'm doing is that I'm just putting them in the order that they're written down. I'm not worrying about ordering these bits, the leaves, and that's because I'll do the ordering on the next table. So 42, 18, now I've been talking and doing that at the same time, so if I've made a mistake I'm sure you'll have spotted it. So there we go, so there's one, and if we did that, so far we've got 1 mark, and these questions are always worth 3 marks. So what we'd have to do now is we'd copy this into the table, so the stem of 1, and then we'd need to take these leaves and put them in order, so 7, 8, 8, 9, and then the same for the next one, so 0, 0, 1, 2, 3, 5, 9, and then let's keep going, so 3, 7, 7, for the 30s, and then 4 and a 2 for the 40s. So far we're up to 2 marks out of those 3. For the last mark we're going to make sure we put the key on, and we'd write something like 1 with a line and then a 7. Some people are leaving the keys there. Make sure you put that means 17. Don't put an equal sign here, put means 17. So 1 line 7 means 17, because that was, if we look back at the original data, those are the numbers from 17 up to 42. They could ask us for the range, which would be the highest piece of data, take away the lowest piece of data from this, or they could ask us the median or something. But remember, if it's the range, it's 42, take away 17. If you're reading numbers out of the tables like these, make sure you pay attention to the key. Next. 225 grams of flour are needed to make 9 cakes. Marion wants to make 20 of these cakes. She has 475 grams of flour. Does Marion have enough flour to make 20 cakes? Now this sort of question, usually they give you the whole recipe, and in this case they're just telling us about how many cakes and how much flour. But if you remember these questions, we start with 9 cakes, we want to get to 20 cakes, and we've got to get there by timesing and dividing. Now this is a bit of a tricky one. We're going to have to actually divide by 9 to work out how much flour we need for 1 cake, and then times by 20 to work out how much flour we need for 20 cakes. But it is a calculator paper, remember, so we can do those calculations without too much problem. So 225 grams of flour for 9 cakes, so 9 cakes is 225. So we're going to have to divide that by 9 and then times it by 20. Oh, times by 20. So just reaching for my calculator now. 225 divided by 9 has given me 25. And then times that by 20, and I've got 500. Now I think about it, we could have done that without a calculator, couldn't we? But never mind. So we've got 500 grams of flour is what we need for 20 cakes, and Marion has 475 grams of flour, so does she have enough? The answer is going to be no, she needs 25 grams extra, and it does say you must show all your working. So we should probably say something like, there's our rough working out in an exam, make sure we're making things clear, but if we wanted to just take that rough working out and make sure there's enough information on there, maybe just put an arrow and say 225 grams for 9 cakes, 500 grams for 20 cakes. So it's not lovely setting out, but it will get us the marks. And so final answer is no. And if we want to have some bonus points, she doesn't have enough. She would need another 25 grams. Okay, now I've put a circle around this one. It's not technically something that we've done this year. This is actually a distance time graph. We've not actually seen these this year, but it is the sort of thing that if we look at it carefully and think about it, we can get the mark. So let's have a look. Simon went for a cycle ride. He left home at 2 p.m. The travel graph represents part of Simon's cycle ride. So here we go. At 3 p.m. Simon stopped for a rest. How many minutes did he rest? So let's have a look at this graph. Here we are, start at 2 p.m. and then we travel for a while. And that point there, look, if you look at 3 p.m, it goes up to there where the graph goes horizontal. So that flat bit is his rest, and that lasts from 3 o'clock to this point here, and that's exactly halfway between 3 and 4. So how long did he rest? Well, that's halfway between 3 o'clock and 4 o'clock. That's half an hour, so that is 30 minutes. So we can have a go at that one. How far was Simon from home at 5 p.m? So we'd have to go to our graph, go to 5 p.m, go all the way up to the line and then across, and we get 20 kilometres from home. So how far from home? 20 kilometres in that case. Now, at 5 p.m, Simon stopped for 30 minutes, then cycled home at a steady speed. It took him 1 hour 30 minutes to get home and complete the graph. So at 5 p.m, he stopped for 30 minutes and then took 1 hour and 30 minutes to get home. So stopping for 30 minutes, we know that that looks like this, a horizontal line. Just obviously be a bit careful, make sure you're drawing it with a ruler and so on. It's difficult to draw it in exactly the right place on this iPad. And that takes us up to 5:30, and then it takes 1 hour and a half to get home. Well, 1 hour and a half after 5:30 is 7 p.m. So when he gets back to no distance from home, that's going to be 7 p.m, so he's going to hit this point here. And then we would get a ruler out, and again, I haven't got a ruler here, so horrible wobbly line, but we'd get a ruler up and join those up with a straight line for the next mark. Okay, we've got a four-sided spinner. The table shows the probability the spinner will land on 1 or 3. Now, if you look at the spinner, it has to, sorry about that, it has to land on 1, 2, 3 or 4. So these 4 probabilities in the table have to add up to 1. And it shows the probability that it lands on 1, and it shows the probability that it lands on 3. The probability that the spinner will land on 2 is the same as the probability that the spinner will land on 4. So I know that this number here and this number here are both the same. So what I've got is I've got 0.2 plus 0.1 plus 2 lots of something or other. So that's something or other, I'll call it x equals 1. So those two together make 0.3. So that means that these two gaps all together are made of 0.7. Okay, so 0.7 in these two gaps plus 0.2 plus 0.1 gives us a total of 1. So that means that these two gaps between them have got to be half of 0.7 each, so 0.35, and if you need to, you can type that in your calculator and do 0.7 divided by 2. Another way of thinking about that is that we've taken this equation here and we've solved and found x there. So if you like equations, then you could deal with it using equations. If you don't, then you could just deal with it thinking about what have we got to add on to get up to 1. Now, this is a dotted line. I think most people should be able to tackle this by now. So it was a dotted line around here, but this is not included in the main set of marks. At the start of the video, I said that we had 14 marks that we might be able to get. This is included in there, but hopefully you've seen this enough times now that we're starting to get the idea. She's going to spin this spinner 200 times, and we want to work out an estimate for the number of the times it will land on a 3. So all we do is we take the probability of landing on a 3 and we times that by how many times? So 0.1 times 200. 0.1 times 200 is the same as 200 divided by 10, so you don't even need to get the calculator for that one, but you could if you wanted to check it. Next question. So we can see a circle and the diameter marked on it straight away. So before I even read the question, I'm thinking, okay, I know that circumference is 2 times pi times radius, and I'm thinking the area is pi times radius times radius. So I'm just remembering those two, and then let's see, we might need those, we might not. So John has a flower garden in the shape of a circle. The diameter of the garden is 5 meters. John wants to put fencing around the edge of the garden. the fencing costs £1.80 per metre, work out the total cost of the fencing. So I'm going to need to know the distance around the edge of the garden if I'm going to work out the cost. Well, that distance there that I've just sort of marked on in red, that's the circumference, isn't it? So we need to do the circumference is 2 times pi times the radius, and the radius here is 2.5. So circumference equals 2 times 3.14 times 2.5. Don't forget there's the diameter there, but our formula works with the radius. If we didn't do this in lessons, but you might have learnt elsewhere that circumference is pi times diameter as well, if you want a different way of getting there. But from the lessons, we only use the one formula. So 2 times 3.14 times 2.5. I think that's a case of using the calculator this time. So 3.14 times 2.5 times 2. And my calculator is giving me 15.7 for that. So my circumference is 15.7 metres. And the fencing costs £1.80 per metre. So if there were 2 metres, there'd be 2 lots of £1.80. If there were 3 metres, it would be 3 lots of £1.80, and so on. So it's 15.7 metres. So that means that we need 15.7. So the cost is 15.7 times £1.80. And if we put that in the calculator, excuse me, pressing the wrong buttons here. Here we go, 15.7 times £1.80, 1.8, and I've got here 28.26, so £28.26 for our final answer, and that's worth 3 marks there. Now then, Mr. Watkins needs to buy some oil for his central heating. Mr. Watkins can put up to 1,500 litres of oil in his oil tank. There are already 850 litres of oil in the tank. Mr. Watkins is going to fill the tank with oil. The price of oil is 67.2 pence per litre. Mr. Watkins gets 5% off the price of oil. How much does Mr. Watkins pay for the oil he needs to buy? Now, the first thing I'm going to mention here is this 67.2 pence per litre. When we've done questions like this and they've given us a price like that, 67.2 pence, some people have thought, does that mean £67 and 2 pence or something like that? It doesn't. It means 67.2 pence. Now, I know that if you're buying something, you can't buy it for 67.2 pence exactly. But in this case, what we're talking about is if you bought 2 litres of oil, it would cost twice as much as 67.2, and if you bought 6 litres of oil, it would cost more than that. So imagine if you bought 10 litres of oil, then that would be 672 pence, or in other words, £6.72. Okay, so sometimes you can have a litre of oil costing not a whole number of pennies, but 67 pennies and a little bit more. Of course, if you bought 2 litres of oil, then you still would have to pay to the nearest penny. But if we're buying, in this case, look, hundreds of litres at once, then it makes sense to have 67.2 pence per litre, because that 0.2 pence when you're buying several hundred litres might make a difference. Okay, so let's go back to the question then. Mr. Watkins can put 1,500 litres of oil in his oil tank. There are already 850 litres of oil in the tank. So let's work out, first of all, what's useful, what do we need to know here? Well, hopefully the first thing we need to know is sort of obvious. We need to know how many litres of oil does he need to buy. So we need 1,500 minus 850, which is 650 litres. Oh, sorry, 650 litres, there we go. And the price of oil is 67.2 pence per litre. So what I'm going to do, and you can do this different ways, but I'm going to find out the total price of oil, and then I'm going to take the 5% discount off. So I'm going to say total cost is 650 times 67.2 pence. Now that answer that I get out of my calculator now is going to be in pence, and I'm going to want to change that into pounds at some point. So 650 times 67.2 is what I'm typing in the calculator here, and I've got this answer 43680. Now remember, that's in pence. So if I want to change that into pounds, I need to divide by 100, because there's 100 pence in a pound. £436 and 80p. Okay. So that is the price if he doesn't get his discount, but then so the total cost there was before the discount, which we might want to write down before discount. Again, apologies for the handwriting on this iPad, it's a bit difficult to make anything neat. So we want £436.80 and we want to take away 5%. So the way that we usually do this is we find 10% of £436.80. There are other techniques as well, of course, but this one I think is the one that most people in our class this year are using, so I'm sticking with this. So 10% we divide by 10, 5% of £436.80 is half of that. Well, half of £43.68 might be alright without a calculator on that one, but you are on a calculator paper, so let's just check this. £43.68, and I'm dividing by 2 on my calculator, and I'm getting £21.84. So Mr. Watkins in this case is paying £436.80, take away 5%, which is £21.84, and I'm going to put that in the calculator as well. £436.80, take away £21.84, and I've got this answer, £414.96. Peter goes for a walk. He walks 15 miles in 6 hours. Work out Peter's average speed, giving it answer in miles per hour. Now this is a dotted line because, again, we haven't covered this in lessons this year, but some people have been having a look at it. It's something we might want to be able to do. So 15 miles in 6 hours. So what we might remember is that speed is distance divided by time. So that speed is 15 miles in 6 hours, 15 divided by 6. And if we type that in the calculator, again, we get the speed is 2.5 or 2.5 miles per hour. So if we just remember speed is distance divided by time, which you may well have seen before or in science or something like that. Now, 5 miles is 8 kilometres. Sunita says that Peter walked more than 20 kilometres. Is Sunita right? So show all the working. So this is one that we have done this year. It's a conversion question, but it's a little bit out of context. So again, it's got a dotted line. We might trip up on this one in the exam. So 15 miles is how far Peter's walked. We can see that from up here. Look on the first part of the question. So if he's walked 15 miles, well, if 5 miles is 8 kilometres, then, oh, excuse me, just making a mess here. Right, 5 miles is 8 kilometres. What have I got to times the miles by to turn them into kilometres? Well, if I take the miles, if I divide by 5, I get 1 mile, and then if I times by 8, I'd get 8 kilometres. So divide by 5 times by 8 is how we're going to get from miles into kilometres. So from the miles here, I'll divide by 5. It's the same as the recipe sort of questions that we get. It's a proportion kind of question. So divide by 5 and times by 8. Well, 15 divided by 5, don't even need a calculator for that one. That's a 3. Times by 8, 24 kilometres. Sunita says that Peter's walked more than 20 kilometres. Is she right? Yes, he's walked 24 kilometres is our final answer. Again, watch out there. There's a little star on this, which means the setting out is important. So you want to make sure that you're a little bit clearer than what we've just scribbled down here. And make sure that you would write down Sunita is correct, becoming at the end. Now, number 8 here. This is a trial and improvement question. And I've already drawn on here the table that we need. So whenever you see a trial and improvement question, draw this table down and you're most of the way to getting your first mark already. Now the way that it works is this. We've got to try different values of x, and it's just finding a number by guessing is all that it means with trial and improvement. So x cubed means take the number and cube it. We've got a calculator here. So we've been told there is a solution between 2 and 3. So I know that 2 is too small. I know that 3 is too big. So I'm just trying 2.5 to start with. So on my calculator I'm typing in 2.5 and I'm finding the cube button, but I could just type in 2.5 times 2.5 times 2.5 because that's what cubed means, but x cubed is 15.625, oops, sorry, when x is 2.5, and then I'm taking away 3 lots of x, and in this case x is 2.5, so 3 lots of 2.5, so that would be 7.5. So I'm on my calculator, I'm doing 15.625, and I'm taking away 7.5. And what's come out of that is 8.125. Now, the answer that we want is 15. So our comment is that that is too small. And if we keep going with that, we'd say, okay, well, 2.5 is too small. So imagine the number line here. 2 is too small, 3 is too big. So we've tried 2.5, and that's too small, and 3 is too big, so we can cross this bit out. So where are we going to try next? Well, I'd try somewhere like 2.7 or 2.8. So I'll go for 2.7 first of all, and if I work that out, I'd do 2.7 cubed, and I'd write the answer that comes out of the calculator there, minus 3 lots of 2.7, and I'd write whatever comes out of the calculator there. And I'm cheating a bit here because I'm getting these numbers off the mark scheme, but if we did that, we'd have 2.7 would give us an answer of 11.583 ... and some other things. So that is still too small. So we've narrowed it down to 2.5, 2.7 is too small, so we can cross this bit out, and we're in this gap here between 2.7 and 3. And if so if we try 2.8 and 2.9, what we end up with is that 2.8, write some working out in here and write some working out in here, but 2.8 would give us 13 and a bit, 13.55-ish, and 2.9 gives us an answer of 15.6, and so on. So 2.8 is too small, 2.9 is too big. Now, a lot of people stop here, but watch out. It says give your answer to one decimal place. Going back to up here, look, what we've now done is we've replaced this picture with a different one. We've replaced this with the picture that we know we're somewhere between 2.8 and 2.9. So let me just rub this out and show you what we're talking about. So let's forget all that. We know that we are between 2.8 here and 2.9 up here, and I don't know which one the answer is closer to. So I know that one of those two is the right answer, either 2.8 or 2.9. And by the way, if you've got this far, you've usually got 3 marks out of 4, or 2 marks out of 3. Let's just check this question. How many marks is it for? It's a 4-mark question, so we've probably got 3 marks out of 4 here. But we need to find which of these is it closer to. So what I'm going to do is I'm going to try halfway between. Now, halfway between is 2.85. When I try 2.85, I find that, again, do all the working out, show that in here, but I get 14.59-ish, something like that. And that is too small. So I know that the answer is between 2.85 and 2.9, so my final answer has got to be 2.9. It's closer to 2.9. Before I tried that 2.85, I didn't know whether the final answer was 2.8 or 2.9. I didn't know which one to go for. So we have to do that and make sure that we've got it fully right. Okay, I'm going to pause there and carry on in a different video because we've done quite a long time already.